Hello, I'm Dr. G. Today we will solve an equation which contains sine of x, cosine x, and tangent of x. Start the solution with finding of admissible values for x. We have here sine of x in the denominator. It means that this sign cannot be equal to 0. First restriction is sine x not equal to 0. And this gives us an equation that x cannot be equal pi times k. Next, we have tangent, and we know that argument of tangent cannot be equal pi over 2 plus pi times k. For our case, it means that at these values, tangent doesn't exist. We move pi over 4 to the right, simplify a little this expression, and finally we have that x cannot be equal minus pi over 2 and plus or minus 2 pi times k. We can summarize what we found here, and as a next step, we rewrite equation in terms of tangent x over 2. This method is very often used when equation contains different trigonometric functions. To do this, we will use some trigonometric identities which are shown here. For tangent of difference, we will use here for sine and cosine alpha as function of tangent alpha over 2. We start with this tangent, and we will apply first equation. So we have this expression. Tangent pi over 2 is 1. Then we denote tangent over 2 as y. And we have for this tangent this simple expression. Next, we go to the second term. We apply second equation. After some transformation, very simple, so I skip them. We have the following fraction. And in the numerator, we have 1 plus y squared, and in denominator, 2y. Cosine x is equal to this expression. Next, we will plug in what we found into original equation. First tangent, then second term, and cosine. And as a result, we will have the following equation containing only y. So we have algebraic equation here. Next, we represent 1 plus y squared as a product of 1 plus y. And on the right-hand side, we replace 1 minus y squared as this product. We can take into account this restriction for x, which means that y not equal negative 1, y is tangent of x over 2. For this reason, we can cancel here, and we can cancel these terms here. And the equation becomes more simple. We can factor 1 minus y. And now we need to solve this equation. We have product of two terms equals 0. So one of them equals 0. First, we can see that 1 minus y equals 0. So y equal 1. This is first root. Or we have tangent x over 2 equal 1. And for x, we have this solution. So we have first x equal pi over 2 plus 2 pi k. Next, we consider this term as 0. So we have another equation. We know that x not equal pi times k, so y is not equal 0. And we can transform this equation to this form. This is a quadratic equation. We can apply formula for the roots of quadratic equation, and we will have y2 equal square root of 2 plus 1, and y3 is this one. You can verify this yourself, I believe. So we have for x2 this formula. For x3 we have this formula. And we can find x2 and x3. And this is a summary. What to do further? Actually, we can consider this as a complete solution, because actually we can calculate this square root plus 1 with calculator and find arctangent. But here we can find this arctangent as fraction of pi. With this requires some work, and I will not do this here. You can find the link to the video where this is explained in the description to this video. So using this, we can represent x2 and x3 in more simple form, and our solution will be here. The problem is solved completely. If you have other solution, then please leave a comment and I will reply as soon as possible. And if you like this video, you may want to hit like icon, leave a comment and subscribe for the channel.